This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Good morning, good afternoon, good afternoon. And well, I guess it could be good morning, depending on when people are watching. But it is November the 12th, and it is a great day to have you here um, with us for the Math Map Book Club. And we are looking at lesson 16. So we are working ahead, so we don't expect anybody to be on lesson 16 on November the 12th, but we want you to have access to the equipping ready to go when you hit the ground after Christmas in January. So that said, we are indeed on lesson 16, which is triangles and circles, which is Lee's name for trigonometry. Lee recognized that for many people, trigonometry might be a word that's associated with frustration. When we think about that idea of easy things being familiar and hard things being unfamiliar, historically, we've got trigonometry in our traditional education of trying to get people to learn both the grammar and engage with it dialectically all at the same time. And without giving people the time to really get that grammar solidly in, trying to be dialectic is more than frustration. And so recognizing that she decided to change the title for this lesson to Triangles in Circles to emphasize how we can connect this idea of trigonometry and right triangles to the coordinate plane, which is a more algebraic way. So it's a really great way to understand this interlocking of the geometric and the algebraic. So that said, every week we start by talking about our flashcards. And as we're thinking about this coming back into our formal school time after the holidays, you may or may not have been keeping up with the flashcards. In either way, in either case, our strategy for this week is to take time to read the fronts of the flashcards. So the first time we talked about reading the flashcards was really emphasizing these are unfamiliar. We need to read them first. But as we start practicing, we stop reading those fronts out loud because we're focusing on getting the right answer. So my encouragement for you is as we come back to starting the second semester, we maybe come back to our flashcards if we've taken any time off, is to take some time to read the fronts before your student gives the answer. That's going to let you practice reading the notations. It's a great opportunity to review cards, and it's a good reminder to revisit cards that maybe had been mastered. Maybe you haven't looked at some cards in a while. And so using that foundation skills. So our foundations families may say, I've already been doing this, where our challenge families maybe had gone to just getting the answer. Remember that when we talk about our foundations memory work, we always want to give a full and complete answer, a complete sentence. And so reading your front of your flashcard, right, whether it's addition, 3 plus 3 is 6, and not just saying the answer 6, right? Is a great way to practice. You could even encourage your students with the notations, right? This symbol means the geometric mean. It's a capital pi, something like that. Depending on the level of your student, how in depth you want to go. But that's a great way to review those flashcards by reading the fronts before they say the answer. As we look at our covers, we're back to our core habits of memoria. So that's our names, naming, attending, memorizing, expressing, and storytelling. And as we look here, the first two are a little bit similar. But it sort of goes, I think, right one way or the other. So if you want to practice naming, you could point to some things that are in the art or on the page, especially things that may be related to your to the topic, right? So it says triangles and circles. So I might want to point to a shape and ask my students, what's this shape? What's this shape? What's this shape? So that they're have to say, well, it's a circle. Or I might say, right, that would be my naming. My attending might be, okay, look at your art here. Can you see a triangle? Right? Oh, well, these look like triangles. They may not be perfectly triangles, but they have that triangular shape, right? This looks like a triangle. So encouraging our students to either name, right? We point out something for them to name or to identify is a great way to practice naming and attending. We've talked about memorizing the number and the title together. But we have maybe not talked about locating that on the math map. In connection to the cover, right? So when we think about our math map, we've talked about that, but looking at this and going, okay, well, what dimension is this in? It's here in the corner. So where would that be on the math map? And encouraging your students to close their eyes and picture, where do you think you are on the math map based off of your cover, right? So that's a little bit of a different experience to looking at the math map and identifying where you are, but saying, okay, I want you to picture the math map and see where you are based off of cover elements, right? So whether it's my domain, my dimension, or my lesson. Oh, an idea for expressing is to ask your students to draw a picture that's inspired by the art. I think this week is a particularly good week to encourage our students to create some kind of design like this. They had the opportunity to use their tools to create sort of daisy designs and mandala-ish designs in lesson 14. You could always pull that forward and say, okay, well, how could we use our tools to create something that's similar to this? And then as we think about storytelling, right, um, that should say any, right? One of the things that we think about when we think about storytelling is the idea of characters. So as we look at our reflection and our quotation, we could ask our students, well, what are the characters? Right? Plato says, then my noble friend. So who is a noble friend? What does it mean to be a noble friend? We could talk about the character, right? Elizabeth Elliot says, teach me. So her prayer was, right, for herself. So who was she, right? So we could talk with our students about who the characters are, right? And I'm using that in a very generic sense, characters, but who are the people that our quotes are addressed to, who are being exhorted in there? Anything you guys would like to share about talking about our covers?
That last thing you talked about, I think would be interesting for older students who feel like they've seen this cover 3 years in a row and they want to go deeper. And I think that would be something, maybe even letting them at home look up those people, do some research about those people. Um, one thing I remember, we were kind of attending to the artwork one year, and one of my kids said, and I don't know that I would have picked this out, but that there were triangles in every corner that were black.
Ooh, I like that.
And they're not perfect triangles, but you do see the shape of, and I don't think I saw that in several years. So I thought it was really cool that they can still point out things that we haven't seen. Every student's going to be different. So
Mhm.
there's always going to be new, new and different things that they can, bring to the table.
And it's kind of like an inscribed circle in a polygon,
Ooh,
and
I
the
like that.
remaining shapes are triangular.
Oh,
That's
that's good. I like that.
I think, and that's a great conversation, isn't it? Like, what is the definition of a triangle? But why do we recognize that as a triangle? Why does it look like a triangle to us, even if it isn't perfectly a triangle? Is it perfectly a circle? Not really, because it's right. If you were to trace it, you wouldn't get a circle, but we recognize that it is a circle. And so talking with our students about this idea of math, right, especially our older students, a mathematical definition of circle or a mathematical definition of triangle, but yet, right, if we look out into creation, when we say, oh, well, there's a circle or there's a triangle, do we mean a mathematically perfect?
Mm.
Or, right, how do we recognize that? How do our brains recognize that? I think that's a great conversation to have.
One other thing, when I see this photo, I always think of kaleidoscopes. And I'm curious, I don't really understand how kaleidoscopes work, but I mean, I think there's mirrors that are making the angles that make the circle. Anyway, it just feels like that might be a related tangent to go off on.
That would be really fun. It would be fun to find an inexpensive kaleidoscope, let your students look at it and use it, and then cut it open and see how was this made. I think that would be a really fun activity. Maybe at home versus in community, but I
Yeah.
think that would be a fun thing to do.
I was just thinking too, could you compare the week, I think is it 12 polygons, the snowflake with this? Because I don't know why, but for some reason I just thought of the snowflake when I saw this. So I don't know if you could compare those two, let your students compare those two and see what kind of connections they see or what differences they see.
I
Hmm.
like that idea. Of course, on day one, we encourage you to always take a look at your math map and know where you are. Put your check mark on there with your students for lesson 16 and then in their appropriate domain. Because we just want to continue to practice where are we. Right? That's why we have a map, is to know where we are, to be able to look back, to look ahead. And so helping our students to anchor where they are on the map is helpful. And then our strategies for lesson pages. So we're going back around. So we gave you 15 different strategies in the first semester. So we're going to revisit those in the second semester, but maybe take a slightly different look at them. For you as a parent who are preparing to lead this lesson, where we started with at the beginning of the year was, hey, practice different strategies. By the end of the semester, you maybe found the strategies that were the most straightforward or the ones that worked, or maybe they didn't work, but you fell into that pattern of doing the same thing from day to day. And so a great way to prepare for the second semester is to think back over the first semester. Ask yourself these led to the richest conversations or to aha moments, or effectively loading grammar, completing lesson pages, which strategies felt easier for you, which ones maybe that needed more one-on-one attention, and were there other activities that were perhaps better if you had everybody at the table together? So taking a minute, not just to assess, we talked last week about assessing the teacher and all of those things. Take what you learned from that and think about going into the second semester by intentionally looking at the different strategies that you maybe experimented with and determining which ones were helpful, and then use that to help you make a plan for the second semester. I think that the lessons themselves, right, at this point are going to be fairly straightforward, especially in all of the domains that we've released. But the content is likely to become more unfamiliar for families who are in their first year of the math map. Right? When we think about trigonometry and matrices and differential and integral calculus, right? Those may be concepts that are less familiar. So don't be afraid to experiment with those weeks. and determine how do we approach this so that any anxiety we have over the unfamiliar doesn't get transmitted from teacher to student, right? Because remember, for them, this is all new. There's nothing that's coming from past experience for most of them. And so for you, if you have had past experience that wasn't positive, right? How do we leave that behind? And so where we look at the strategies that worked, it helps us to keep our focus on those learning skills, on those strategies, and less on where we maybe feel that we don't have as solid a grasp on the math content.
I think that's a great idea. I think too, you know, I've heard people say, well, I don't want to just talk about these 15 skills over and over again. But the whole reason to do it over and over again is so you learn how to do it, because most of us don't really know how to do it. Like, I mean, we're learning, and we learn a little bit more every time we do it, but I don't think we're masters of it. And so it might seem like, yes, we're covering the same questions, but the point of that is that every time we see something brand new, we just pull out those questions and we just start over and ask those questions. And so it can everything can be approachable. So I've heard that, like, don't tell me to do the 15 skills. Like, I already know how, but are you doing it? Like, are you really doing it? Just have a cheat sheet and just do ask the same questions. And then the next time you come across something that's so unfamiliar that you get scared, to even attempt it, pull out your questions and do it again.
That's a great reminder, Babs. Yeah, I think as as we come into CC, as we start our homeschooling journey with younger students, it's a little bit easier to rest on, oh, we're developing the skills of learning and I'm rising up a lifelong learner. And then something happens when we're starting to hit those high school years. All of a sudden, there's that pressure of, oh, I've got to have my transcript done and we need to learn this and they need to be prepared and I've got to check these boxes. And somehow we're tempted to like throw those learning skills out and become content focused. And we really want to encourage all of our families, from our youngest learners to our oldest learners, right? So looking in the mirror, we really want to encourage you to see the importance of emphasizing those skills of learning. Because if we really have mastered those skills of learning, if we get to the point where our kids are automatically naming and attending and memorizing and expressing, and asking good questions about the circumstances or the relationships or identifying the testimony or coming up with good definitions, if they're using their memoria and their delivery is clear and complete, right? If they're doing all of those things, they can be successful wherever they go. And having just recently graduated two students and sent one off to college and the other off to the Marines, I've seen firsthand how they have pulled a lot less from the content they learned and a lot more from those skills of learning, right? That they're pulling from those skills of learning. And, my son, he's like, well, I just remember he had to do presentations, right, at combat engineer school. Mom, I always came up with a good exordium and it really made a difference. So they're taking those skills of learning, those skills of presentation, of delivery, and right, they're succeeding. And so I'm like, wow, this really worked. So my
Yes. Can I
testimony
share one
is
more
that
quick
yeah,
testimonial
please
along
do,
that line?
Jana.
My daughter's roommate in college, they're seniors now, and they both did CC all the way through. And her roommate is a very, very intelligent person, and she kind of had expressed this frustration with 5 common topics, I mean, whatever. But she said she's been taking note all through these 4 years of college, which professors have the most enriching, the best professors. She said they're the ones that use the 5 common topics every time. They are the one, that is what they're doing. And she's just came to that conclusion. She's like, I'm totally bought in now. I just, it's not just rhetoric. These tools actually work. So I thought that was exciting.
That's a really great testimony. So yeah, so bear with us because it does feel like we're hammering these home, but we're doing it for a reason. So that brings us to our page 1 set, where we are taking a look at introducing these ideas of these trigonometric ratios. And I think there's a lot of grammar in this lesson. And my daughter actually remembers, she's like, Mom, I remember that you told us if all we did was memorize like the first page of the charts, like we'd be ahead of 95% of high school seniors. And I was like, well, and that's true. But she remembers that years later that I said that just getting this grammar down is going to set you up for success everywhere else. And so we want to continue to look at the grammar here and notice that that's what we're practicing with our students. Is trig is such a grammar heavy subset of mathematics that if you don't take the time to memorize and to build your memoria, you will continue to be frustrated. Students are going to see this again in lessons 25 and 26. We're going to see it in almost every lesson between lesson 16 and lesson 30. In almost all of those, not every single one, but in a lot of those, students are going to see these ratios pop up again and again. And if they don't remember what does that SIN and that TAN mean, they don't remember that, they're going to be frustrated. So this really is a lesson where I cannot emphasize enough the value of memorization and adding to your memoria. Are there any questions from page 1? Right. On day 2, our frame page is our I² invention page. And again, right, we just talked about this. What's the purpose of the invention page? To practice the 5 common topics of invention. But this week we're talking about relationship. And so things that we could talk about are just talk with your students. Well, how is math ordered? Right? They might say, well, look at the math map, right? There's an order there. There's an order of dimension. There's an order of domain. Looking at this page, right? Could we think about things that are a before and an after? So you could practice your order on our coordinate axes. So as I go from left to right, how are my x values ordered, right? Well, 0, 1/2, the square root of 2 over 2, the square root of 3 over 2, and 1, right? So we see how they're in order from left to right. How are my y values ordered? Well, going from bottom to top, I go from 0 to 1/2 to the square root of 2 over 2 to the square root of 3 over 2 to 1. Now they might recognize, right, the inverse nature of those 2 orders, but notice that we're going from smallest to greatest. Then you might say, well, can you go from greatest to least, right? Now I'm going to go backwards along my axis. We can also practice order on the unit circle. That's where we could practice our angles, right? We go from 0 to 30 to 45 to 60 to 90. In radians, we go from 0 pi to pi over 4 to pi over 3 to pi over 2. Right? What's the reverse order? Right? Pi over 2 to pi over 3, pi over 4, pi over 6 to 0 pi. And that might seem like it's not that difficult, but especially with our radians, especially with our radicals here, right? Helping our students to put those values in order is going to help them to build up their number sense, right? Because a lot of them might go, well, I don't know how big square root of 2 over 2 is, right? If I don't remember that square root of 2, that's about 1.414, so 1.4124 divided by 2, right? So there's a lot of calculations there that it's not an intrinsic understanding. But if we practice this order, putting them in order, all of a sudden, without calculating, our students are going, oh, well, yeah, square root of 2 over 2 is bigger than 1/2. Square root of 3 over 2 is less than 1. Or pi over 4 is between pi over 6 and pi over 3, right? So putting numbers in order is going to hard. Another thing that we can do when we think about relationship is think about the idea of cause and effect. And I think the one way we can do that is just say, well, how does one value change another? So anytime that we have an equation, right? So even the slope equation, right? If my change in y is positive and my change in x is negative, how does that change my slope? Oh, well, they're different. It's negative, right? So those are some cause and effect, right? What's happening with my x and y is going to change what's happening with my slope because it's an equation. We could also look, especially at these identities here, and say, well, what doesn't change, right? What isn't affected in the equation? Well, here, notice all of these have a 1, right? That's a constant. What does it mean if it's constant? It means it doesn't matter, right? If I change the tangent, secant has to change, but 1 will never change, right? Nothing's going to change that 1. That's what the whole idea of an identity is that that 1 doesn't change. Right? So those are some cause and effect questions that we could ask. And remember, the idea is not to necessarily understand the math, but to help our students come up with ways that they can examine relationship, right? So in doing so, we're going to build our math understanding. We're going to build our math intuition, but our goal is to really help them to learn how they can ask good relationship questions. Anybody have anything they'd like to share? Jana, you looked like you were thinking.
I'm just having light bulbs. They're not coming on. They're just flickering like an annoying fluorescent bulb a little bit, but it's coming. We just looked at the unit circle in class yesterday. We spent a lot of time looking at it, and I'm just, oh my goodness, there's so much here that I don't understand, but I'm really excited that there's, yeah, flickers.
Yay. So on day 2, or we look at page 2 as part of our day 2 sequence here. Are there any questions from this set of pages? Love that, right? We're just going to practice these curves over and over again. So by the time our students finish with the math map, they're going to know what the graphs of the trig functions are. Somebody was going to ask a question.
Hey, Kirsty, it's Kristen. So I am just looking at this one from the Challenge B book, the cosecant, cotangent, tangent, and secant. Can you just briefly explain? Like, I've never seen those ones in relationship with the other. I'm good with inside the circle, but not outside the circle. And this is
This
new.
part right here.
Yes.
So, well, I was going to talk about this at the end, but we can talk about it here.
No, that's fine. We can wait. I can wait till the end. That's fine.
Just because I had Babs pull that out so that we can look at it bigger at the end, because I promised Andy that we would talk about the relationship between tangent, right, tangent to a circle and tangent. And that's what we're practicing there. So we'll come back and take a deeper dive into looking at that diagram. So Babs, you could even pull this one or the one from the chart and stick it on that slide. Thank you. That's a really good question, because it is not, it's not something that I necessarily was super comfortable or familiar with, but over time, I'm growing in my familiarity. So it'll be a good conversation. On day 3, our strategy, our focus is memoria and arrangement. And so as we, again, look at those 5 core habits of memoria, we are on storytelling this week. And I thought, why not actually just use some of the things that we talk about when we talk about storytelling? character, setting, and problem, right? Because usually we are thinking about a story where we have a person who is our character and they're in a place and they're trying to solve some problem. But we can use that same idea um, to talk about our I-cubed memoria and arrangement page. Right? When we're talking about the character, right, the question is who is the story about? Or in this case, what is this page about? What's the main idea? And helping our students just to read our headings, right? Sometimes we skip over these, even if we shouldn't. Sometimes we go, oh, yeah, I know what's up there, right? But teaching our students, well, this is about ratios on the unit circle. Okay, right? So where do you see a circle on this page? Right here. Okay, do you think that's the unit circle? Maybe, since that's what it says, right? So maybe that's my main character is this idea of the unit circle, right? Um, it might be harder for our students to see ratios, right? Because some of those are hidden, right? They might look down here and our older students might go, well, there's cosine, sine, and tangent, right? Here's my trig ratio word. So maybe now I've connected that. But just asking our students, right? What's the page about? What's the big idea? Anytime we're looking at a page that's overwhelming, whether it's a page of text, whether it's a piece of art, or whether it's a technical document, a great question for us to ask is, okay, well, just what's the big idea on this page? Why is this page even here, right? Who's the character in this story? Then we can think about setting, right? How is this page arranged? Or how is the topic arranged? Right? So I could look at the page itself. There's this big box at the top. And I already said, well, this is the circle, right? There's my main character. He got the big piece of the page. And then there's more information down here. So maybe I notice that this is where the ratio word shows up. And I might start to connect some of these numbers to this diagram up here, right? And so I'm looking at how my page is arranged. How are things separated out on the page? What's the setting? I could also think about the topic. Well, what's all this stuff here on the unit circle? So that would be more aligned with understanding or looking at the math, right? Well, again, I could look at my angles. My angles are getting bigger as I go around, right? I could look at these numbers and go, oh, wait, so on my x-axis, I have 1/2. I've got this same pattern here from 0 out to 1. And then my y's, I'm getting that same pattern. Right? And then our problem that we could ask is maybe how are these related, right? So I've got these different sections that are all somehow tied together, right? How are they related? What problem are they solving? How are these ideas related to one another? Any comments on our core habit of storytelling? Great. Looking at our 3 set, I think if you look at the charts, and then you start to see it here with, I think more, because here they're sort of doing some copy work. They're doing a little bit more here. But this idea of these trig formulas, these sum and difference formulas, if you have students who have any desire to go on and succeed in calculus, these are some of the most helpful, right, formulas that they're going to use. Now they're helpful for using what we know to find things that we don't know, right? So I could use 45 degrees and some of these formulas, and I could calculate what the sine or the cosine of 22.5 degrees is. And I could use that to go halves, right? So I could use known values to solve for unknown values by using these formulas. But for those students who continue on into calculus, that's where you're going to see that this is really going to set them up for success. So I think the opportunity to start adding these to your memoria early on is going to help our students, both those who are not going on, right, that are perhaps looking for practical ways to use these formulas, but also for those who do have some goals to get into engineering or anything that's going to involve some calculus, that you're really going to be glad if these are in your memoria. Day 4 brings us to our careful calculations. And my idea for you this week is that you could work behind to plan review opportunities. So instead of lesson 16 on day 4 doing lesson 16 careful calculations, right? Maybe you go back and you pull lesson 14 or 13 or 12, and you save lesson 16 for the following week, or a week where maybe it feels like it's going to match, right? So maybe lesson 25. So I could take these and say, okay, I want us to review these trig formulas right before we do lesson 25, where I know we're going to see some trig again. So I want it to be fresh for you. So maybe in lesson 24, I'm going to have you do this careful calculations page. So you can rearrange how you're using those careful calculations pages to create your own review structure. So that was my idea for you this week, using the careful calculations pages. That may not be a great strategy if you're in your first year of the math map, but as you become more familiar with the math map and what's in each of those lessons, I think that you'll start to see where you could use those. And that's also a good argument for having your students do, especially our older students, write their work on a separate piece of paper so that we can use this page more than once. And that brings us to our 4 set. Are there any questions from this page? So just a reminder of all the ways that we're here to support you. I just continue to say thank you to Babs, who is just tireless in answering people's questions. We so appreciate her and just how hard she works. Next week, we will be meeting and talking about lesson 17, which is intersected shapes. In December, we will be meeting and answering whatever questions you want to bring. So we are not planning to have a very structured time, but really would appreciate it if you sent us your questions, and we will be happy to answer those. And then those 3 weeks are the weeks we're not meeting. So the day before Thanksgiving, Christmas Eve, and New Year's Eve, we will not be meeting, which brings us back to lesson 18 on January the 7th. So here's some questions that we have. So let's take a look at this one and go in a little bit greater detail here. So the question was, how is the tangent related to the tangent of a circle and tangent itself? So I'm going to, Babs, do you want to make the side pages a little bit smaller and the middle one a little bit bigger so we can see that? Do
you want to see the big chart? Do you want to see the
no,
chart bigger?
no, the page 2, the I page. Sorry, the middle piece. It was page 2, not the I page. Page 2, the one you have in the middle. If you can make the outside pieces smaller and the middle piece bigger, then we can all take a look at that. So while Babs is just doing that. I'm going to go ahead to the next slide and answer that, and then we'll come back, and that way we're not all sitting here staring at Babs. So a question that was sent in was looking at y equals negative x plus 3 and understanding how it is that we graph that. And I thought it was a good question because it maybe highlights how incompletely associating our grammar over time can lead to some misunderstandings. So we're looking at this one right here, right? And as we talked about last week, our first step is to say, right, is it a dashed line or a solid line? It's an or equals, so is that dashed or solid?
Be solid.
It's solid because that is going to be included in our solutions. So our second step is to always look at the related line. So y equals negative x plus 3. Especially with our students, when they look at this and it's still unfamiliar, the question that we might want to ask them is, what is the model equation that we know about lines? In other words, what's the equation of a line that doesn't have numbers, it has letters, but do you remember that? Or can you go back and look that up? Does anybody know, anybody on the call, what would you say? What's our model equation for the equation of a line?
Y equals mx plus b is 1.
Yep, yep. And so we look at this, and here's why taking the time to write that is helpful, because now I can match. What does b match to in my given equation?
Positive 3.
Positive 3, right? So I'm going to write here. So b equals positive 3. What does b mean? What is b?
It's where your line is going to intercept the y-axis.
Good. So we call that our y-intercept. It's, right, just as you said, where the line crosses y. And so what point is that? If it's the y-axis, what's my x coordinate on the y-axis?
0, 3.
Be 0, 3. So I know that that's one of my points. Okay. Now, let's take a look. We know what our b is. What is our m? What does that match to?
Slope.
Say that again?
Slope.
Slope. Right. So my m is my slope. And what number does it match to in my original equation?
-1.
-1. Now, this is a case where, right, some students might struggle to see the 1. So we may have to remind them about the hidden 1, right? And so this is -1. What is the formula for slope?
Rise over run. Or change in y.
Change in y over change in x. Mm.
Okay, so there's two parts of this, right? There's my numerator and my denominator. So when I think about my slope with that -1, I'm not just talking about an x value. And this is where a student might have that misconception that b is a y value, right? It feels like that's a y value. So is that -1 an x value? And so that's where we want to help them, right? If they're right when they're still learning, we want to help them to remember, right, that it's not the ratio of our change in y to our change in x. So if this is -1, what does that tell me about the signs of my change in y and my change in x? What are the two possibilities?
A negative numerator or a negative denominator.
Yep. So then I would say, okay, well, what does that look like? Well, if my change in y is negative, I'm going down. If my change in x is positive, I'm going right. Or if my change in y is positive and it's going up, then my change in x has to be negative and go left. So 1 tells me that my magnitude is the same. So going up 1 is going left 1. Going up 5 is going left 5. So now if I have my point here, I can say, well, if I go left 1, here's my left, I'm going to go up 1. Or if I go down 1 and right 1, either of those are going to give me a point on my line and let me graph this. So let's talk about which skills of learning that we just used. When we identified our model equation, what skills of learning did we use?
Naming.
We could have used naming,
Memoria.
Definitely attending.
attending. Yeah, so when we match, that's definitely an attending, isn't it? We're attending. So then when we looked at what B and M you meant, what skills of learning did we use?
What B and M meant. From Memoria, to remember that that was the y-intercept.
Yep. Would you say that that's definition?
Oh, yeah. Definition.
We
And I
had to
feel like that's
define.
this whole thing is comparison, right? We're comparing the x and the y values, and
We did some comparison.
we're how I want to say relationship because but I feel like relationship and comparison often get muddled in my brain. But what's happening what's happening to y in relation to x, or what's happening to x in relation to y comes to mind.
That's good. But notice we just spent a few minutes really diving deep, using our skills of learning to understand how we were going to graph y equals negative x plus 3. We may not do that for every exercise on every page, but here's a great example of using our skills, slowing down, and taking the time to ask our students, where do you remember seeing this? Do you remember seeing this in a chart recently? Have we defined this anywhere? Pulling those questions out and helping them to use those skills of learning to rightly assess what they were doing. So now let's go ahead and go back.
I wonder if their question was answered though that they sent in, because do you see what I mean? Are they
Yes.
wondering, like, it
So,
looks.
so let's go ahead and take a look. So when would we are, so if it's negative x, wouldn't you go left? So notice here that we could go left. When we're thinking about this, we have to think about both parts, right? It's not just saying that I have a negative x that I'm going left, but that -1. So first we want to remember that the -1 is our slope. And so it could either be that my x is going left. When my x goes left, then my y has to go up, right? The alternative is that if my x is going right, then my y has to go down.
Okay, I was thinking maybe she was one, it says to shade the intersections.
Oh, I see what you're, so the shading, because I didn't finish the shading, thank you for clarifying there. So the shading, that's our last step, is to go back and look, right? And so because we want where y is greater than, we're not, this part here, the negative x plus 3 is just to give us our line. Then the shading all comes from this inequality here. And so I want to know, where is y greater than? And that's going to be above that line. Thanks, Jana, for clarifying.
And what about the equal to? Does that matter?
That is what determines whether we use a dashed line or a solid line. If it was
Gotcha.
strictly greater than or strictly less than, that's where we would use a dashed line.
And there is a second line in that box. See how it says
Yes.
line 4, x is greater than 1. So you would actually have a dashed line that would go across. Yeah, there we go.
Yeah.
So the intersection, shading the intersection, we would just go in between those two. Correct?
Right. That would just be in here.
That would just be in here. That would just be in here.
Where it's both greater than our negative x plus 3 line and to the right of our x equals 1 line.
Okay. Where both of those are true.
Yes.
Okay, got it.
And that's this piece here, right? That's important. That's an attending question because it's and. If we had said or, next week when we look at lesson 17, you're going to see more of those cases. If we had said, where is this true or this true? Then I would have shaded this. I'm running out of colors. Orange, there we go. If it was an or, I'd be shading all of this.
And that would be the union instead of the intersection, right?
Exactly. Yep. Any other questions?
That definitely confused me. When it's or, you shade more than when it's and?
So let me erase this. Yes. So let's go back to highlighter and let's do this way. So where is it greater than y equals negative x plus 3 is all of this, right? This is where that's true.
Mm-hmm.
If it was to say where is x greater than 1 is in all of this area.
Mm-hmm.
Where are both true? Right? Where are both true is only here where it's right, blue and green. That's where both is true. But if I said, where's at least one of those true, right? That would be my or. Then it's everywhere that's shaded.
Gotcha. Oh, I got it. Okay.
Now in 17, we're going to see we could also have an exclusive or, which means that it's one or the other, but not both.
That's what I was thinking this meant. And in that case, it would be, but it would be like the top left triangle and the bottom.
Yes. If it was an
right,
exclusive, if it was exclusive or, I'm just going to do this x or.
I can't see that.
Then it would be just here and here, but not where both are true.
Got it. I think that's what I was thinking, like, how could it be? I think or in my mind was always exclusive or, but you're saying either or versus exclusive or. Got it.
That would be kind of like when we're talking in one dimension, union versus subsets, right?
Mm-hmm. Yeah. Yeah. So when we having that sort of set thinking process with these to help our students go, oh, well, these are all the points that make that true. That's a set of points. Yep. Okay. All right, so now let's take a look. Let me change my ink color from orange. So let's take a look at our unit circle here. And when we think of sine and cosine, I think it's perhaps that's the easiest one for us to look at our unit circle. And if let's just take a look at this triangle here and recognize that this value, and this value are what we expect them to be. Because if I was to look at this, I don't know why I'm using my mouse. Let me undo that one. So if this was 30 degrees and we knew that this was 1, we know some things about a 30, 60, 90 triangle. Right? If I was to draw the rest of this triangle out, it would be a 30, 60, 90 triangle. What is true? I mean, an equilateral triangle. What is true about the sides of an equilateral triangle?
All the sides are the same length and all the angles are the same.
Right. So all my sides are the same length. So if I chop that in half, and I know that this side of my original triangle was 1, how long does this half side have to be?
1/2.
1/2. And if my hypotenuse is 1 and my short side is 1/2, what do I know has to be true?
The remaining side squared has to fit right there.
Yep. So if we were to use our Pythagorean theorem for this and solve this, we would get that this is the square root of 3/2. If we now take that back up and we put this back over here on our unit circle, right, we see that here's my 1/2, here's my 1, and here's my square root of 3/2. Now, if I was to look at this and I said, well, the sine of 30 is my opposite side over my hypotenuse, I get 1/2 over 1, which equals 1/2. If I was to look at my cosine of 30, I would get the square root of 3/2 over 1, which is the square root of 3/2. The unit circle, so this is specific to the unit circle because my hypotenuse is 1. My y coordinate is always going to be my sine of my angle. And my x coordinate for this point is always going to be the cosine of my angle. And this is true for every angle. So that's where we see here, we have the cosine and we have the sine of our angle. And by definition of the unit circle, this value is 1. So now the question is, right, how do we get the rest of these? And some of it, I'm not going to give you a really great math definition. We're going to more take a look at this from a grammar perspective. But if we were to look at this line here, the line that is this line is tangent to the unit circle at our point, xy. The tangent is going to be, we know it's sine over cosine, but it is also the length from the point of tangency to where that line crosses the x-axis. And the cotangent is from the point of tangency to where it crosses the y-axis. And so now we see this relationship between this tangent line and the tangent of the angle. Again, when we're talking about the unit circle, if we were not talking about the unit circle, we would have to scale this up, okay? So these relationships are going to hold true, but everything would have an R next to it. All of these lengths would have R's next to them.
R meaning radius.
R meaning radius, yes.
Because when the radius is 1, you don't.
One,
it
that goes away. Yep. So that's the hidden, right? So there's a 1 here next to all of these that comes from that 1 being the radius of the unit circle. If that 1 was something else, we'd have an R everywhere else. But it's just a lot cleaner. So that's why we like to look at the unit circle, because then we don't have to worry about the R, because it disappears and we don't have to worry about it. So these 2 points where this tangent line crosses my X and Y axes then also become important, because we see that the secant is the distance from the origin to the point where the tangent line crosses. And notice that the horizontal is cosine and secant, and they're inverses of one another. And our cosecant is our Y value. And notice our cosecant and our sine go together because they are both, right, the cosecant is the inverse, or sorry, reciprocal of the sine, right? They're reciprocals. So cosecant and sine are reciprocals, cosine and secant are reciprocals, and then cotangent and tangent are reciprocals. And so that's how the tangent line to a circle is connected to the tangent. And again, this is not a man-made, right? This was not, man didn't sit down and say, well, let's just make this be true. It's inherent in the mathematics that this is true. I think that's kind of cool.
Understatement.
I love every time you say man didn't come up with it, but it's inherent in the mathematics. That just always makes me happy.
What a discovery, though.
That always makes me think of, do you guys, well, I don't know. I've been around long enough to remember when there was a catechism for challenge A, and one of the questions was, what is good science? And it was always like, the answer was like, oh my gosh, I'm drawing a blank right now, but the continual observation of God's creation or something, something, something. And that makes me think of, what is good math? Math is probably just observing and discovering what's already true in creation, which is pretty cool.
Seeing the unseen.
Seeing the unseen. In our vision statement that we wrote for the logic strand, we say that math is man's expression, right, of God's inherent order. So we may have come up with the words and the symbols, right? Those may be those may be man-made, but the truths that we're expressing are God created. They are God's truths, not our truths. And so helping students to recognize this is true. They might not ever understand why it's true. They may not dive that deep into the math to know why is this true, but to know that it is true, that these ideas are connected, and this is how they're connected. It starts with draw this diagram. Draw this diagram, and over time it's going to become more and more familiar, and we're going to go, oh yeah, that's what we're working towards. But Andy, does that help answer your question? And Kristen, does that help answer your question from this one?
Yes, that was perfect. Thank you so much.
You're welcome.
The
I never
question
knew
was not
why.
mine.
I just memorized that cosine and secant were opposites, and that's all. I just knew that if we were in the realm of the secant, cotangent, cosecant, tangent realm, that I just had to remember that cosine was one way, and it was secant that went with it, and then cosecant went with sine. But now I see how they're related, and so that's beautiful. So thank you.
I'm hoping my
You're welcome.
technology's finally working. Can you hear me?
Mhm.
Yeah,
Yes.
I've been struggling all hour. So, what would be really fun, I think, is to take a pencil or a short stick or toothpick and lay it on top of the diagram Kirsty just did on the hypotenuse equals 1, and then move it up and down, rotate it a little bit so you can say, all right, so now is your tangent getting longer? Is your cotangent getting shorter? If your tangent's 1/4, your cotangent has to be 3/4 of the line. Like, just talk about all those relationships as you go around the first quadrant. And then eventually the other 3 quadrants fall into place because they're just the sign changes, but the relationships are the same.
Mm.
It is very neat. Kirsty did a great job explaining that.
Has if anybody has the trig trainer, right, that's a great tool for exploring this.
And it's on sale right now if you don't.
The CC bookstore, is that what you're talking
Yeah,
about?
yeah.
Mm.
Are there any other questions? Does anybody have anything else that they would like to ask or talk about today?
I have a question. My daughter and I were talking about regular versus irregular shapes today. And her question was like, by definition, does that mean like isosceles and scalene triangles are never regular? Since they have
Yes.
to be.
Well, isosceles triangles, so yes and no. So if we were to look at a scalene triangle, by definition, no sides are congruent. That's an R, right? Therefore, that is never regular. However, here is one of the greatest mysteries on the charts, because we've had several people say, I think that you have an error because the spacing is wrong. So here's the reality. By definition, an isosceles triangle has at least 2 congruent sides. So on the chart, there's an indentation underneath that to show that an equilateral triangle has 3 congruent sides. So if an isosceles triangle is equilateral, then it's regular. If you tell me it's an isosceles and you don't tell me anything about the third side, I'm going to say it's a question mark. Is it regular? Right? I need to know a little bit more information. I need to know, is it also equilateral or is it just isosceles?
Yeah, we had a great conversation about like, how can an isosceles triangle be an equilateral? And I was like, it's the same way that a square can be a rectangle, but not the other way around.
And there's another great conversation when you're thinking about with triangles, right? We know that if it's equilateral, then it must also be equiangular. But that's not true with any other polygon, because we can have equiangular and we can have equilateral, and those are both not regular. Only both equiangular and equilateral is regular. And that's true for any n-gon where n is greater than 3. I can have an equilateral heptagon. I could have an equiangular heptagon that is not regular unless it is both equiangular and equilateral.
Okay.
That answer the question, Andy?
Yes. That's very cool the way God did that.
That's why triangles are so special. They're this like foundational shape. They're so special in ways that their shapes aren't quite the same, which brings us to the whole idea of the trinity, right? And the
I want to add to that. So there's basically nothing in nature that's a true triangle. And I think Lord reserved it for himself.
Now I feel like I'm on a mission to find the triangle in nature.
Go for it.
I was
Go.
searching the
Yeah.
database.
But I can't think of one, but I was just like thinking like, wow, that's crazy.
You can see some rock formations that get super close that are crystalline. But if you look at them, I mean, that would almost be an anomaly if it was. Like something got chipped, you know.
My thoughts would be, what about like all those problems that we had in math where like you had to figure out how tall the flagpole was based off of its shadow and you being so far away from the flagpole.
Mm-hmm. Yeah.
now here's the question though. Almost all of those require us, right? This is the trigonometry booklet, right? What is the foundational shape for trigonometry? What's true about one of those angles?
90 degrees.
90 degrees. So all those exercises that you remember, Andy, are predicated on using right triangle mathematics. If a triangle has a right triangle, is it equilateral? No.
That's so
But
weird.
but could it be isosceles?
Yes.
It can be isosceles, but it can never be equilateral. Unless you're not in Euclidean geometry, right? So
Mm-hmm.
if we're looking at spherical geometry, you can find the idea that where it bends around the globe, that's the easiest context. If I had the prime meridian and then I go 90 degrees along the equator, right? That's a 90-degree angle. And then if I take 90 degrees, so I go up the meridian, those meridians are going to intersect at the pole and have a 90-degree angle. So that would be an equilateral triangle that all has 90 degrees, but that's not in the geometric system that we're working in here.
Which that by
So
itself is an interesting conversation because there's so many other systems. But until you understand dimensionality and rectangular versus polar, your mind doesn't even go there. It wouldn't know how to.
Whew, my brain's full for today.
Same.
Yeah, I agree.
This was great.
well, thanks everybody. Remember to keep sending in your questions. We're happy to work through those and dive as deep as you would like at the end. And so that time only gets better when you give us the questions to go over. So please keep bringing those. And Andy, tell your daughter, keep sending those in, because I love it when you're like, well, my daughter has this question.
And what I
So
love about
she
it the
always has
most,
some really good questions, lead to some really great.
right, and I love it the most because, like, last year there was much weeping and gnashing of teeth at this point in the program, and I love it that now she's like diving deeper into it, and because she has a little bit of grammar from last year, and now it's like, oh, I love these questions.
Wow.
All right,
Just a
you guys have a
reminder of
great
how
week.
important
Oh,
that
sorry.
grammar is. Nope. Thanks, Babs. Yep. We'll see everybody next week.
Hey.